Hello, thank you for watching this video. So in this video I'll be doing question 5 of November 2020 question paper, Mathematics paper 2, which are trigonometric functions. As you can see, they are drawn here. So I'm going to read the statement before I proceed to answer the questions that follow. So now I'm reading. The graphs of f and g for the interval from x is equal to 0 to 180 are drawn below, and A is an approximate point of intersection of the two graphs. So you are given two graphs, f and g, with these equations that are here, starting from 0 to 180 degrees, right? And you're told that A here is the approximate point of intersections of the two graphs. Again, you're given two graphs, f and g, with these equations. That are these two graphs of yours are defined by these two equations. F is this one, which is this. G is this one, which is that. And you are told that this is their approximate point of intersection, and they are defined from 0 to 180. That's what you're told by the statement. So let's answer the questions that follow. So write down the period of G. So they're asking you to write down the period of G. First question, what is the period of G? So the period of G, okay, so you must first understand that when you're dealing with a cos function or sine function, you are dealing with periodic functions, right? So what do I mean by periodic? So I'll draw examples here. So I'm going to draw sine x here. So here sine x. So this is sine x, 0, 90. This is 180 here. This is 270 here. This is 360 here. Right? So this is sine x from 0 to 360. It stops there. So let's say it continues again. So if this graph here continues, let me get another color. If this graph continues from here, go up, then it comes down here. Right? This is what your graph will do now. Goes up again and comes down there. So if you look at this first part, this orange part, it looks the same as that blue part, right? So if you look at the first part, the orange part, it's exactly identical to that blue part. So by periodic functions, those are functions that are repeating. So from 0 to 360, it was unique. There were no repetitions. But from 360 to 720, then you can see that your function will repeat from there. That's what we mean by periodic functions. Those are functions that are repeating themselves. So it's more like you have this function, then you have this part, and then you add multiples of it on this one. Because if you draw another wave here, it will be one wave like that, and again for another 360 degrees. So that's what a periodic function is. Then what is a period? Then a period is the time it takes for one is the time it takes for you to get one full wave. So now here, so we're at 0 here. So we get one full wave here, or a single wave or a pulse is a time to get one complete wave, or a time you take to get a pulse. So now, which means now it is the time it takes for you to start here and get to this point here. So now, how long did it take you to move from the start of the wave to get to a point where your wave is complete? How long is that? So now you start here, you go there. So this is your period of the wave, this here. So your period of the wave is 360 degrees in this case, because it is how long it takes you to get a complete wave. So to get a complete wave on the sine function, it takes you 360 degrees. Because from here to here is another complete wave. It's another 360 degrees, if you think about it. Because here, it's going to be 720 here. It's going to be 720. So now, all the bits of the extension of other 360s will be a repetition of this. You will be repeating this part of your wave. That is what your period is. So similar thing with cos. So now, for cos x and sine for sine x and cos x on this state, right? Their period is 360 degrees. They have a period of 360 degrees, which means if you have cos x or sine x, after every 360 degrees, they keep on repeating. It's the same wave, but you keep repeating the same wave. That's what a period is. Okay. So now, how do you calculate the period? So I'm going to do these, and then we're going to answer the question. So to calculate a period, you say, okay, if you're given sine x or sine ax or cos ax, so if you are given, let's say, if you are given sine ax and cos ax, and we are asked to calculate the period of these functions. How do you calculate the period of these functions? You say, okay, you know for your sine and cos that your period is 360. For sine, it's 360 degrees. For cos, 360 degrees. What is the period of this? So how do you calculate the period? That's what we want to know. So to calculate the period of sine or of cos, sine ax or cos ax is equal to 360 degrees divided by a. That's how you calculate the period of a function. It's 360 degrees, which is that of cos and if you want the period of cos or sine, it's 360 degrees divided by a. What is a? A is your coefficient of x here. A is your coefficient of x. So if you have 7, you divide 360 by 7. That's how you'll find the coefficient. That's how you'll find the period of sine. If you want that of cos, so the coefficient here of x, you divide it by, you use it to divide 360, then you get the period. For example, in our case, if we want the period of cos, we're going to say 360 divided by a. What is our a here? Our a is 1, which means now here you divide it by 1, and your period will come out to be 360 degrees. If you had 2 here, you're going to put plug 2 here, and it was going to be 180 degrees. That's how you calculate the period of a function. So to calculate the period of cos or sine, it's going to be 360 divided by coefficient of x. So now let's answer our question. So now they want us to calculate the period of g, right? So the period of g, what function is g? G is a sine function. We know a standard sine have the period of 360, right? So if you want to find the period of G, it's going to be 360 degrees divided by K, where your K is the coefficient of X. That's what your K is. K is the coefficient of X. To find the period of G, it's going to be 360 divided by K, where the K is the coefficient of X. And then we say, okay, 360 degrees divide. What is your K? Then you go to your function, G. What is the coefficient of this X here? The coefficient of this X here is 1, right? Then you are going to have 360 divided by 1, because the K is the coefficient of X. What is the number that is in front of X there? So your period is equal to 360 degrees. That's how you calculate the period of your function. If you wanted the period of f, you're going to go say, okay, what function is f? F is cos, right? So now, you know that the function, the period of cos is 360 degrees. Then what you're going to do, you're going to have a similar situation. 360 divided by k, and then you divide with your k there, which is 1. It is also 360 degrees. That's how you calculate the function, the period of a function. Let's go to the next question. Write down the amplitude of f, right? So they want us to write down the amplitude of f. What is the amplitude of f? So here is f here. So they want you to write down the amplitude of f. So f, the amplitude of a wave, or of a sine function or a cos function, it is the maximum height or the maximum depth of the wave. How deep is it? Measuring it from the x-axis. From the x-axis going vertically, up, down, or going upwards. What is the maximum height your wave or your function can have? What is the biggest value of this distance here? Or what is the biggest value of this distance here? Because this is f, so we're looking at f. So what is the maximum height this wave can have? If you can have that maximum height, then you have the amplitude, because it is the maximum distance from the x-axis vertically, or the maximum distance from rest position, which is this. So when they want the amplitude, they want the maximum height this function can possibly have, or the maximum depth, either one of them. If you can find one, questions now the maximum depth or the maximum height, then you are good. How do you do this? You say, okay, if you had all this function here clearly drawn, because of course it is not drawn to scale, maybe you would be able to calculate, to look at the maximum value of the maximum height of this, or the maximum depth there. Take one, they are fine. But now it's not drawn it's not drawn in scale, right? So now you must find other means of finding your amplitude. So to find the amplitude of a function, you say, okay, the amplitude is equal to the maximum value of your maximum y value here minus your minimum, all divided by 2. This is how you find the amplitude of your wave, or of a function, or your sine function or your cos function. This is sinusoidal stuff. So if you want the amplitude, you say the maximum value minus the minimum value. So now your responsibility is finding the maximum and the minimum of this function, and then divide by 2. But if you can get maybe the maximum, you can just take the maximum. If you can get the minimum depth, just take the minimum depth, but the positive value of it. That's what you can do. Okay, so come and look at cos f. F is a cosine function. So if you can try to draw it, it's one of those that I'll expect you to know. So x0 is 1, this, and that. So this is how your cos function looks like. So this is 0, this is 90, this is 180, this is 270, and this is 360 degrees. This is your cos x. So you can see that here your maximum value is 1, your minimum is -1. So I said the amplitude, it is the maximum height of the function. So your maximum height is 1. So here your amplitude is 1. Or you can take the maximum depth, which is what? Which is -1. But take the positive value of it. That will give you amplitude. Because the maximum depth is -1. Then what you do is you take half of this. So you take the positive sign of this depth here. That's how you get your amplitude. But here you are asked to get the amplitude of negative cos, right? So now if you're getting an amplitude of negative cos, which means now you are halving this function here. You are taking the negative half of this function here. If you want negative cos x, so it's a negative half of this function. That's exactly what you do. So you are taking a negative half of this. So if you take a negative half of this here will be -half to be here, -1/2. This here will still be 0. This one here will be +half. This one will still be 0, and that one here will be a -half. So this is how your function will look like now. This function is -1/2 cos x. So you took the negative half of that. So which means you multiply all these values by -1/2. So -1 times -1/2 times this, you get a -half. 0 times is going to be 0. -1/1 times -1/2 is +1/2, and so on. So here is your function here. So your maximum value is 1/2, and your minimum value is -1/2. So you can say here on our formula, our amplitude is equal to the maximum, which is 1/2 minus our minimum, which is -1/2, all divided by 2. Then you can punch this on a calculator. You will discover that your amplitude is 1/2. But you didn't need to do this if you can see on your graph that our maximum height of the small function is 1/2. So the amplitude of this graph is 1/2. That's how you find the amplitude. Then we move to the next question. Determine f at 180 minus g at 180. They want us to find f at 180 minus G at 180. Right? So that's basically what they want to do. They want you to find this without using a calculator. So it's more like they're asking you f of at 180, which means put your 180 there, minus 1 over 2 cos 180 degrees minus sine 180 plus 30 degrees. That's basically what they are asking you to do. Right? So this is also 1 mark. So now I'll delete the ones above so that we can deal with this alone. So let's delete them. One thing you should always keep in mind here is when you're dealing with trigonometry, is that you are dealing. So one thing that you should keep in mind when you are dealing with this kind of situation or kind of questions is your, for example, see you have 180 here, you have 180 plus 30 there. So this will require your cast method or your cast something. So this it's 0 degrees, 90, 180, 270, and 360 here, right? So the angles that are the values of theta that are here are between 90 and less than 90, greater or equal to 0. That's what you have here. So you have a theta that is less than 90 or greater or equal to 0. What does less than 90 mean? This means that we have 90 minus theta when your theta is greater. Oh, so which means you have 90 minus theta if your theta is greater. If your theta is greater than 0. If your theta is greater than 0. That's what, so all the values that are here are less than 90. That's what this says. And then here, they are greater than 90, the values of theta that are here. And also not the value of theta, but your angles that are here. If you have an angle that's that moves from this point to that point, is greater than 90 degrees, right? And is less than 180 degrees. 180 is less than 180, right? And if it's here, it's greater than 180. If it's here, also less than 270. Here, if your angle is here on this quadrant, spanning from the first quadrant, spanning from here to here, that angle of yours is greater than 270, but it is less than 360. So I would say these are things that you should always have in mind. So you should always have this in mind, that the angles on the first quadrant are greater or equal to 0, but they are less than 90. Right? So less than 90, which means they are 90 minus theta, where your theta is greater than 0. On the second quadrant, they are greater than 90, so it's 90 plus theta, assuming that your theta is positive. Of course, also, they are less than 180, so it's 180 minus theta. Here, they are greater than 180, it's 180 plus theta. Also, because if you do 270 here, all angles that are on the side are smaller than 270, so it's 270 minus theta. So if you're here, they are greater than 270. If you're here, they're less than 360. So here, all your trig functions, which means sine x, cos x, and the tan x, they are all positive here. All of them on the first quadrant, they are positive. I will explain this when we're giving classes. But for now, we're still doing the videos. Once we get a bigger audience, then we can have motivation to give lessons. But now, we're only giving the solutions to the question papers that you guys are doing already in school. So here, only sine x is positive. Here, tan x is positive. Here, cos x is positive. So here, on the first quadrant, I said all the functions are positive. On the second quadrant, only sine x is positive. Tan x and cos x are negative. On the third quadrant, only tan x is positive. That means sine x and cos x are negative. On the third quadrant, on the fourth quadrant, only cos x is positive, which means now your tan x and your sine x are negative. Okay, so let's go to this. So you know that cos of 180 is minus 1, so we have minus 1 over 2 times cos 180, which is minus 1. Minus. So when you have something like this, this is what you do. You say, okay, you ask these questions. Okay, I have sine 180 plus 30. Where is 180 plus 30? Right? Your 180 plus 30 is on the third quadrant. Here is it. Here is 180 plus 30. It's on the third quadrant. Then, what sign is this function on the third quadrant? Only tan is positive on this quadrant, so the sign is negative. So now, what you end up having, you'll have negative sine of 30 degrees. Because this 180 is giving you the quadrant, so you're only left with 30 degrees. So the simplified version of this is this guy here. It's negative sine 30 degrees. Then you simplify this. 30 is a special angle. Say 1 over 2 plus sine 30, which is 1 over 2. That gives you an answer of 1, which means your f of 180, f at 180 minus g at 180 is equal to 1. This is how you do this. So this is very important when you deal with this kind of situations. You ask yourself, where is this? It's on the third quadrant. What sign is your function on the third quadrant? It's negative. Then you drop that, then you take the sign of that. Then that's it. So your answer is 1. So let's go to the next question. Okay. 5.4 now. Use the graphs to determine the values of x in the interval from 0 to 180, for which let's read this question again now. So to use the graphs, which are these graphs, to determine the values of x in the interval from 0 to 180, for which f, this function here, is equal to that function here. So they want us to find the value of x in which this function here equals that function. So what we had f of x and g of x, right? But here we have f at x minus 10 is equal to g of x minus 10. What does that mean? What does that tell us? So what that tells us is that this function here have been shifted 10 units to the right. So both of these functions, they are shifted 10 units to the right. So, which means now our original functions are shifted 2 units to the right, which means now if they were starting at 0 here, which means now this is 10, which means now they are starting at 10. They will move and start maybe somewhere here at 10, which is this first value will be here, and this first value will be there. And then they will still maintain the same shape, because these are the exact same function, except that now they have been shifted 10 units to the right. So if you're shifting 10 units to the right, these two guys will shift 10 units, even A will shift 2 units, which means now they will still be equal at A, but our A now will have shifted 10 units. Because what you do here on this, what you did here is to move those functions f and g 10 units to the right. That's what you did. So now, like I say, if you move, so that means your function will shift 10 units to that side, including your A. So they will be meeting exactly at a similar point as A, but that is 10 units to that side. Which means now, since they were meeting at 130, they will be meeting at 130.9 plus 10 units, because you have shifted the same functions 10 units to that side. You haven't changed anything. So this is what this tells you. It tells you that your functions have been shifted 10 units. So if you're saying it's shifted 10 units, even your A, which is your point of intersection, it will still be this, the intersection will be similar, only 10 units away from where it is today. Which means now your point of intersection, which is that it will be at x, it will be at x is equal to 130.9 plus 10 units in which you shift the function to the right with, which is equal to 140.9. So your functions will be meeting at 140.9. They will be equal at 140.9. That's how you do this one. Easy, right? So let's go to the next one. So I will need to clean so that I can do 5.4.2. I hope you understand this. Let's move to the next one. So use the graphs to determine the values of x in the interval from 0 to 180, for which the square root of 3 sine x plus cos x is greater than 1. So they want you to find the values of x on which this thing is true. So on which this equation is true. How do you go about this? If you look at this, right, this function here, and you've done compound angles expansion on trigonometry, I will assume maybe you've done that already. If you know how to expand compound angles, you will see that this looks like an expanded version of this. Except that instead of having, because you'll be having sine x, because if you expand this guy here, let's expand g of x. G of x is equal to sine x cos 30 degrees plus cos x sine sine 30 degrees, right? So your sine x will remain the same. Your cos x is cos 30 degrees is root 3 over 2 plus cos x times sine 30, which is 1 over 2. So this is how you expand compound angles. We are going to do them, but I assume that you know how to do them. So this look exactly like this thing here, except that it is multiplied all out by 2, right? So if you expand this compound angle here, you get something like this. So now what we should do, we should try to reverse that expansion there, so that it looks like this. So to achieve this part, which means now you need to divide by 2 all throughout this equation. So you divide by 2 here, divide by 2 here, divided by 2 here. So now we have root 3 over 2 sine x plus 1 over 2 cos x greater or equal to 1 over 2. So what this is that, which is now here you have your cos 30 sine x plus sine 30 cos x greater or equal to 1 over 2. Okay, so if you have this, which is now you are here, and you know that this is an expansion of something like that, because once you see the expansion, you can be able to reverse it if you know how to expand compound angles. If you can expand compound angles, then you can be able to reverse by just looking at it. Which means now, this thing of yours, we have sine of x plus 30 degrees, which is greater or equal to 1 over 2. So now, they want the values of x in which your function, this one, is greater than 1 over 2. Then you can look at the function and say, okay, here is 0. If I put my 0 here, I'm left with sine 30. This is 1 over 2, this point here. So now, by extending to this point, to somewhere here, you can see, if this is 1 over 2, our function, this is greater than 1 over 2, all greater or equal to 1 over 2, all this area here. And what are the values of x in that area? That's what you need. You know the first one, that should be 0 here. And then what is the second one? Because our function will be greater than 1 over 2, because this is 1 over 2 line. Our function will be greater than the line y is equal to 1 over 2 in this interval for x is greater or from 0 to whatever the number is there. So the trick is to find that number. I'll repeat again. Our function is greater than 1 over 2, the line 1 over 2, on this interval here, because if this is 1 over 2, here is 1 over 2, and then it will become 1 over 2 there again. Then we need to find what this value is, because our function will be greater than 1 over 2 on this interval. On this interval. On this interval. So we want the x values. Right? So we say, okay, we want more like critical values of this thing. So, okay, sine x plus 30 degrees is equal to 1 over 2. Then x plus 30 degrees is equal to sine arc sine 1 over 2, which is equal to 30 degrees. Right? So, like I said there, when I had the drawing here. So our sign, this thing being negative, means that we're on a quadrant where sign is positive. If your answer here is positive, which means the function that you have is negative on that. So if this is positive, which is the value on the other side is positive, which means that the function in question, which is sign in this case, is positive on that quadrant. Right? So that quadrant is first and second quadrant where your sign is positive. What do you do on your first quadrant? What do you say on your first quadrant? You say you have theta, right? That is greater or equal to theta is less than 90 degrees, greater is less than 90 degrees, greater or equal to 0. That's what you said you have. You said your angle is greater or equal to 0 but less than 90 degrees, right? On the first quadrant. So you solve for x there for the first quadrant. You say, okay, x plus 30 is equal to 30, which means your x is equal to 0 degrees. So this is the first point where this where sine x is equal to 1 over 2, which is that point, which you already know. Now we must find the second point. So it will be on the second quadrant. What do we say in the second quadrant? We say 180 minus theta, which is now your x plus 30, right, is equal to 180 minus theta. What is your theta? So your theta in this case is that. So you have here 180 minus your theta is this here. So you have 180 minus theta, which is your 30. So now you have x plus 30 minus 1, this and this is 150. So to solve your x is equal to 150 minus 30, which is equal to 120. So, which means the other part here, the other point where your function is 1 over 2 is at 120, which means now, from this, you can tell that your function will be greater than 1 over 2 between 0 and 120. So your function will be 0 for x is an element of 0 to 120 degrees, or x less or equal to 120 greater or equal to 0. Because you can just, once you find these values here, the x values here, then it's easy because you can see where it's all above y is equal to 1 over 2. And this is how you do this question. Thank you for watching.